Hello everyone, and welcome to Phosphere Digital Week. My name is Nicolas Aubertin, and I am the Swine Product Manager at Phosphere. Today, we will discuss an important topic in ruminant production, acidosis issue, management of ruminal pH. This webinar is a part of a week-long series addressing key challenges in livestock farming across all species, including aquaculture, poultry, swine, and ruminants. In this session, we will explore the mechanism of acidosis and its impact. We'll then discuss the crucial role of pH in its management. Our guest speaker, Nicolas Anglade, consultant in ruminant at Nutrition and Care, will share his expertise on this topic. Following this, our ruminant product manager, Kanel Gousset, will discuss Phosphare solution with a particular focus on calcium powder advance for 10 minutes. We'll conclude with a 10-minute Q&A session, giving you the opportunity to ask your questions. If you want to ask your questions, you can use the section Q&A and click on the bottom Q&A. At the end of the webinar, we'll do our best to answer as many questions as possible. Thank you for being with us today. We hope you find this session insightful and valuable. Please, Nicolas, if you want to start the session.
Thank you, Nicolas. Introduction. Hello to everybody. So good morning or good evening, depending on where you are. First, I will share my screen. Just a little minute. I will check with my partner if they receive. All right. So today, my first talk will be about technical issues concerning acidosis. And through this presentation, I will try to update what is known on the mechanisms of acidosis and its impact and the crucial role of pH in its management. My plan is to introduce you to acidosis, to define the difference between subacute acidosis and acute acidosis, talk about the fundamentals of acidosis, what happens during this phenomenon, the causal agents of acidosis, the multiple consequences of the SARA, and then talk about how to detect easily acidosis signs at the level of the farm, and to conclude with prevention method. To introduce acidosis, I should like to share with you some numbers. 4 numbers, if you want to remember numbers about acidosis. So the first one is a percentage between 19 and 26. It's basically in the studies, generally, when they are evaluating the number of cows in acidosis situation in standard conditions, it's a number of cows that are at the moment where they are tested in acidosis situation. So 1/4, not far, of the herd might suffer from acidosis. 2.7 kilos. It's a reduction of production of milk per cow, average, that is observed when a cow is in acidosis situation compared to a cow in a normal situation. So when we put that on a standard lactation, it gives something not far from 1 ton of milk lost due to acidosis. Let's talk about figures, and probably those figures are a bit more important right now because of the price of the milk in most of the countries in the present days. When the study was done, it was in 2008. It was something like 1.12 to 1.20 euro per cow per day. Probably today we are more at 1.50. And the last figure is the percentage, it's 10%, and it's connected to sustainability. When we talk about acidosis, we talk about loss of feed efficiency, and this loss can be estimated to 10%. 10% of the diet is not transformed in commercial product, growth or milk. And when we talk about sustainability, I think that the most evident thing with sustainability connected to animal nutrition is feed efficiency. It's to do more with less, so it's to produce more milk with the same quantity of food. So it's important. When we convert that also in economic data, it has been done by in an interview of Mr. Martineau. He was evaluating that to 10 euros per 1,000 liters of milk, which is not which is quite important. Or in other words, 3,500 euros per year on 3,500,000 liter, which is something standard in Western Europe. What is SARA? So SARA, today the talk is to connect SARA with ruminal pH. Here we have two curves of pH. It's following a meal, which is taken at time 0, and we can see that the pH of these two cows is descending after meal. For one of them, it's descending around 5.7. The other one is descending more deep. The definition of subacute ruminal acidosis is that the pH, we are not talking about average pH, we are talking about net pH, and the definition is with two levels of pH. The first one, 5.8, has to be reached more than 5.3, 5.5 hours to be in acidosis. The other one, which is lower, 5.6, it's 3.5 hours per day, so, which is quite rapidly reached after meal, depending on the. When we talk about acute ruminal acidosis, we are not in the same level of pH. Generally, the descent is more intense, and the level of pH reached is generally around 5 or under 5. So it's a critical situation and has to be solved rapidly. When we talk about the consequences, the differences between those two phenomena, what is important with the subacute is that it's frequent, it's discrete, and it's very difficult to detect. So it's a situation where the cow can be for a few hours per day or during different moments of the day, but it's not a continual situation. What is important also, it's repeated episodes. So it can be on several days after transition, can be on several days or in a heat stress. But the effect, and we'll see that later, are very, very fast. The origin, we will go more in detail in the origin, but it's not a surprise. It's an imbalance in the diet, and the cow is ingesting too much concentrate in proportion to the efficient fiber the cow is absorbing. The symptoms, it's subacute, of course, it's discrete, so it's subclinical symptoms. Generally, it's not very, very evident, but it's driving to economical losses. The acute ruminal acidosis is a vet case. It's quite rare. It's sudden, and it has to be rapidly identified. Hopefully, there is clinical signs where you can when you can see that there is a problem. It has to be treated rapidly. It can drive to the death. When we talk about acidosis, we talk about rumen acidosis. So it's affecting first the rumen, which is quite logical because we are considering that the rumen is a pre-stomach. And rumen has to be considered as a fermenter. So in a fermenter, generally, we are trying to control several parameters. One of them is very, very important. It's the pH. And to be optimized, ruminal fermentation has to happen over pH 6. And 6.2 is a good indicator because it's an optimum zone for the fibrolytic flora among all the fibrolytic bacteria. We have the Fibrobacter or the Rhinococcus, which are very, very well known. At this level of pH, the degradation of the fiber is optimized. We have a high production of volatile fatty acids, like acetate or butyrate, for example. Propionate is the other one. We'll see the balance just after. We have also good conditions for degradation of protein. So the protein which are producing ammonia, because we need also, of course, not only volatile fatty acid, but also ammonia. And we have a balanced population of protozoa and methanogens, which are also part of the microbial biomass of the rumen. When we go a bit under, so we are just over 6, in the zone between 6 and 6.2. We have a slight decrease, so we are not in the best zone for fibrolytic bacteria, but they still continue to operate. But we are in the best zone for the amylolytic bacteria, so like Streptococcus, for example, or Bacteroid. And those bacteria are degrading the starch in volatile fatty acids. The fiber degradation is still happening, but not at the same, with the same efficiency. And in the volatile fatty acids, we start to see more propionate production. That might be also interesting in a meat situation when we want to produce growth. There is a slight risk of acidification because at this level we produce more volatile fatty acids. When we are going under 5.6 to 5.5, at this level we have a strong decrease in the activity of fibrolytic bacteria. Basically, they are not degrading a lot of fiber at this level, or they do that with a very poor efficiency. And we start to see a very particular flora, which is a lactic acid bacteria, which is naturally present at the level of the forage. It's the reason why we can do silage, for example. It's because the fresh matter is loaded with natural lactic acid bacteria, and they find very good condition, anaerobic conditions, plus sugar availability to start to produce lactic acid. Lactic acid is not a volatile fatty acid. It's an organic acid with a very strong acidic power. And in this situation, the pH is degrading, so we have a possible accumulation of lactic acid. Hopefully, in the rumen, we still have some flora which are able to use this lactic acid to transform it in volatile fatty acids. It's a lacticolytic flora, but this flora is not directly interesting, and this flora is, of course, consuming energy. It's kind of adaptation of the cow to fight also against acidification. And of course, we are in a zone where there is a risk that the subacidosis is becoming a risk. Under pH 5.5, I put that in red, I should say it's red alert, because in this level of pH, like in the silage, the dominant flora is lactic acid bacteria. And this lactic acid bacteria is able to go very, very acidic to more or less sterilize the rumen. So it's a complicated situation for the rumen, but also for the wall of the rumen. And yeah, So if we look at the curve of the volatile fatty acid, we can see that between 7 and 6, we are in a very, very good situation, a good transformation of fiber, fermentation, production of acetate, which is good. This high level of acetate is good for the fat in the milk. It's a reason why when the pH is decreasing, we have an effect on the fat content of the milk. Propionate is starting to increase, and butyrate are starting to increase between 6.5 and 6, which can be also acceptable for the milk production. When we go more acidic, between 6 and 5, we can see that the lactate production is starting from 5.5, but between 5.5 and 5, there is a possibility of lactate conversion. So at this level, I should say, there is possibility of coming back to a better situation. Also because the cow is producing buffer with salivation to fight against this acidification. After 5, we can see that the lactate conversion is decreasing and the lactate production is increasing with about the end of production of volatile fatty acids. So here we are in a very abnormal situation that has to be treated in urgency. And we are what we can say we are in an ARA situation. The cause of acidosis. So I will try to explain you this graph in 3D, which is very, very interesting. It's a recent meta-analysis where they have taken a lot of different trials. They put cows in SARA. So the red dots are cows in SARA, and the green dots are cows in no SARA situation. And we can see that there is a slide between the left of the graph and the right side of the graph. So it's quite easy to understand. When we take the starch content from the green zone to the red zone, we can see that increasing the level of starch in the diet is increasing the proportion of SARA case. If we go further in this particular indication, it's the part of NDF with fiber longer than 8 millimeters. So what I call useful fiber. We can see that by decreasing this proportion of long fibers, we are also increasing the risk from the red to the green. And finally, the dry matter intake, which is also playing a crucial role in SARA apparition. We can see that increasing the dry matter intake per day is also increasing the risk of SARA. With these studies, they were able to create a kind of prediction equation to evaluate the risk of SARA. So it's very, very interesting and practical. It's something that can be done quite easily on any diet. When we look at other causes of acidosis, it was done in the same study. Here, they compare the different concentrates that you can have beside forages in diets. And we can see here, so we are estimated the mean pH from red to green. All the cereals and all the components of concentrates are not the same. So when we talk about others, we talk about protein sources like soybean, for example, which is very, very also, of course, there is protein, but there is also simple sugars that can create this kind of low pH zone. And we can see also that the corn is not that good. Corn is degraded in more acidic than barley, wheat, or mixed. The mixed is a possibility to mix, for example, barley and corn at 50 ppc, which is quite a good strategy. If we look at the time passed under low pH. So green is the best, and red is the worst. We can see that the corn is not pure corn in the concentrate is probably not a good situation if you reach high level. So between 10 and 20 it's okay, but over 20 there is a risk, and we can see that the mixed strategy is interesting. When we look at the days in milk, so this study is interesting. It was to follow up two problems that we have at the beginning of lactation, which are ketosis and acidosis. We should say, well, perhaps acidosis is connected to the start of lactation. Not so much. The ketosis is more acute during the 91st day, but we can see that the risk of acidosis is increasing with the days in milk, which is quite logical because with the days in milk, we also increase the intake. But we can see that the associated two syndromes are not happening in the best moment, because it's a moment where we are also restarting fertility cycle. So it's associated risk connected to energy that has to be managed at the same moment. If we go further, we can look at the number of lactation, the parity. In this graph, which is not a surprise, we have the dry matter intake and the production of a cow in function of its parity. We can see that it's growing from lactation 1 to lactation 3. We increase at the same time the appetite, capacity of intake, and the milk production. We could say, well, with the time, normally a cow should suffer more from acidosis. It's not the case. It's a bit counterintuitive, but first and second lactation are more sensible to very low pH and time in pH zone higher than cows with 3 lactation and more. It's probably a question of adaptation. I think that the rumen flora is adapting after the time to the situation. So take care with fresh cows, take care with young cows, I should say, because they are more sensible to acidosis than the others. Something which is also very actual. We are depend on the zone where you are, but we are arriving, even if it's not the case today in Saint-Malo, in period where we are talking about heat stress. The heat stress has an effect on the ruminal pH. In this trial, they compared cows with the same diet in the same farm between cool periods and hot periods, and we can see that it is affecting the ruminal pH quite clearly. So in a situation, high forage diet, so normally it's a situation where there is no acidosis risk, we can see that with the heat stress, we are flirting with pH 6, which is not optimal. It's the pH we have in the high concentrate diet situation, but we can see that in this farm, which is very close to Sarah's situation, when the heat stress is arriving, we are losing something like 0.3 points of average pH, which is enormous. It's due to a phenomenon. The cow is like a radiator, which is working all year long. I think it's a 2000 watt radiator, which is working full speed during all year, even in summer. So it's something we don't do at home. And to evacuate this quantity of heat, the cow is thermoregulating with hyperventilation. So it means that the respiratory rate is increasing considerably, which is decreasing the level of carbon dioxide in the blood. And if you have less carbon dioxide in the blood, you have less capacity of producing bicarbonate, which is a problem, because the bicarbonate is a natural buffer for the rumen. A cow is able to produce 2 to 3 kilos of bicarb per day. So it's affecting the capacity of producing bicarbonate for the saliva, which is vehiculated to the rumen with the saliva. So it's letting the pH going down. There is other factors also that are affecting the rumen pH, like the reduced intake. When we have heat stress, generally the dry matter intake is decreasing by a significant factor. So in reducing intake is reducing salivation, so reducing also the quantity of saliva which is arriving to the rumen. And the last point that with heat stress and probably with hyperventilation, there is more drooling, and the saliva is also lost in the nature somewhere. And there is so it's a very, very actual problem with the season, but also with global warming, something that we have to take in consideration. And we have more and more cows also in the intertropical zone that are naturally living in hot conditions. The cows are not naturally made for this kind of climate. Consequences. So it's a complicated stem, but the consequences are very, very numerous with this acidosis. First of all, we have inflammation, which is affecting the papillae structure. It can go to ulceration. So an ulcer is completely degrading the capacity of absorption of the rumen through the papillae. It's also, this structure is also sending signals to the brain. So when it's a bit like gut, which is also a lot communicating with the brain, when this is happening, it's reducing rumination. So it's not very good also for fiber digestion, of course. We have seen that milk quality is also affected by acidosis with the milk fat depression. We have osmotic consequences. It's natural. We have a quantity of acid which is too important for the rumen, so it's asking for water absorption just to rebalance the level of acidity between the blood and the rumen. So it's attracting water to the rumen, and the rumen is drenched more rapidly, creating, for example, watery feces. It's not diarrhea, but could look like a diarrhea, and with undigested grain, fiber particles. So it's accelerating the transit, which is not very good in a rumen situation because fibers need also time to be well fermented. The liver is also suffering. Liver is important in ruminants. It's generally as important as rumen, I consider. With abscesses risk, there might be, if the rumen wall is degraded, there is bacteria that are able to go to the blood system and affect the blood with risk of liver abscesses. There is also a reduced efficiency because the liver has to detoxify a lot of things coming in this situation, because there is other particles which are going through the blood. So it's really tiring the blood function. And the last effect that could be registered with SARA situation are the mobility capacity of the cow. We know that in some conditions, and due to things like histamine or lipopolysaccharides, which are produced by inflammation, or the lactic acid, which is also produced in the rumen and can be evacuated to the blood, can create laminitis in the blood. So it's a kind of congestion which happened in a part where there is no elasticity. The hoof is something very, very rigid, and the cow is lambing. Consequences on the productivity. We have a very, very classical trial here. We have cows in normal situation producing 42 liters of milk, and we create a SARA challenge, acidosis challenge, for 3 days, and we can see that the effect is very, very fast. We have more or less the same kind of response with heat stress. We lose within days 5 liters of milk, and we can see that the recovery of the production is taking time. So it's the time to recover the initial situation is over the 3 days that has been lost during this challenge. Well known also the effect on the milk quality. We have milk quantity, but also milk quality. Acidosis is not affecting a lot the protein level of the milk, but it is affecting the fat. We can see that the fat is increasing when the average renal pH is increasing. So it's quite sensible today because fat is well paid everywhere on the planet, perhaps except in China, but globally the price of butter is, the price of cream is at the highest level we have known on this market. So it's important for farmers. Acidosis has also consequences on growth. We can see growth and appetite. This trial was interesting because it was addressed to a very young ruminants living their first months, and we can see that putting young calves or young heifers in acidosis situation is reducing on the left their appetite and also their weight gain. So it's also affecting appetite and feed efficiency for growth. Fertility. Acidosis is affecting body condition because with reduction of feed efficiency, there is less capacities for the cow to put energy reserves. And if the energy reserves are at the low, it will reduce the ability of the cow to conceive. Of course, if there is a deficit somewhere, the cow is protecting herself, not giving the good condition for fertility. The inflammation, the persistent inflammation of the rumen is also not good for the reproductive system, and there is negative effect on insemination success. And the final point is on hormonal alteration. I just illustrated that with a trial that where we had two separated groups, one normal group and one SARA group with the black dots, and we can see that the level of progesterone that was followed is very different from one group to the other. So it means really that acidosis is affecting the capacity of the cow to come back to fertility. Progesterone is an interesting indicator. Before finishing my presentation, I should like to convert suspicion in certitude. So there is, even if it's not a clear indication, there is a lot of indices that drive you to detect acidosis. For example, I took some examples from my own experience, and it's my own picture I took on farm of situation I met where there was this problem of SARA, and the farmer had the impression to do everything well. And for example, in this farm, the farmer was offering free fiber. It's a hay, big bowl, as you can see, to the cows. But well, we can see that it's not well presented. It was outside. The big bowl was not decompacted, so it's quite difficult to take the grass from that, and you can imagine that the intake was not very. It's something also that you can see on farm. Cows are very, very strong to select the fine particle and the rich particle from the hay, and we can see here that the hay is pushed on the side, and the cow is only eating in the middle. And just to see, it's a very recent video I took in a farm. Here we are in a good situation. We can see that the fiber is present, but it's not so long, it's well mixed. And you can see that this cow is trying with the nose to select, but she has to take the diet. Another sign of acidosis, it's not always this sign, but it's one indication, I should say. It's quite liquid feces, and it's easy with corn because you can see grain of corn. So it's indication. It's not enough. What I advise generally is to do what I call a feces meter. So just take some dungs, put that in a filter, in a 5 mm filters, and apply water. And it's what you can see from washing these dungs. So of course, you have to take the weight before and after to evaluate the part which is not going through the filter. When it's over 10%, well, might be a risk of acidosis or misdigestion of your diet. And there is very, very technical process if you go, for example, through this species method. The last thing I wanted to identify as indicator is the lambing cows. Right, acidosis might create some kind of lameness. A lameness is not always due to acidosis. There is different cause, of course, but one of them is due to acidosis, and it's inflammation, blood pressure, which is sent to the peripheral organs, among them the hoof. And the cow, for this reason, is not walking on the sole, but more on the heel. So for this reason, there is longer hooves. You can see that they are getting longer. We can have inflammation, for example, in the corona zone, this kind of thing. And well, it's observation, of course. It's useful to detect lameness in general. Laminitis is one of the causes, but not the unique one. There is other signs that you can detect. Decreased appetite, more refusal, abnormal refusal of fibers that are not at all consumed. Weak rumen feeling also, it's something that you can observe on the cow. Reduction of the fat content, so there is a ratio which is to follow, it's fat and protein. So we are in the orange zone when we are under 1.2, or in the red zone when fat and protein are at the same level, or fat is under protein, so it's red alert. But also fall in milk production for no reason is something also that has to be observed. Behaviors of the cows, teeth grinding, restless, less rumination, weak rumination, the percentage of cows which is ruminating, or the rhythm of ruminating, which is a bit too low. Discussing also with the farmer, with fast ranges. Generally, I say that if you have 3 out of these 8 points that are checked, there might be acidosis. Rapidly, if we talk about prevention, well, today, and due to some interesting meta-analysis studies, we get more good prediction equations. Sometimes it's private, sometimes it's public, but globally, we have more indicators. The AI also, or artificial intelligence, might help a lot for detecting the acidosis risk. Well, it's always the same question between forage and concentrate intake, useful fiber, a lot of conditions, transition, the frequency of distribution, the TMR technique, following cows for avoiding the sorting. It's stress. For me, it's a growing factor. It's more and more affecting cows, not all the year, but at some time. And there must be a strategy to maintain production, to maintain fertility during this heat period, which are more and more frequent and long. We can also act through the diet by using what I call mineral correctors or feed additives. In the mineral correctors, I think about mineral buffers, and Canel will give us a talk on that just after. It's a direct action on the pH, but at the same time, we are also providing to the cow essential mineral elements. There is also a pro or prebiotics on the market that are directly microorganisms or substances that give good condition to good microorganisms, so to somewhere to be more adapted to the pH. And the live yeast, which is also a good techniques because they consume the oxygen in the rumen, which is also responsible of acidification, and they are able to play a role on the lactate reduction. So thank you for my 5, bit too long, 5 key message. Remember, Sarah is very common but very silent. So a lot of farmers believe there is no acidosis in their shed. Well, let's look if it's real. The economic impact is major. Also, the environmental impact is also important. The rumen pH is the heart of the problem. Remember, rumen is a fermentator. When we are talking fermentation with biogas production, for example, the pH has to be regulated very, very clearly. It is the same with the cows, and it will depend mostly on rationing, but also on farm management. The warning signs are visible if you know how to read them. So educate yourself, educate your teams, because cows have a lot to say, and still very easy to visit cows in the shed, which is not the case with monogastric, but it's a possibility. We have to see the animals, the expression of the animal, and well, prevention is not that easy, but there is several ways to prevent this disorder by nutrition, of course, but also by management, by environmental techniques, thermal comfort, efficient fibers. So thank you for your attention, and I give the relay to Canel.
Thank you, Nicolas, for your presentation.
Thank you very much, Nicolas, for the presentation. Now we'll start with the presentation of Canel. And if you have some question, don't hesitate to ask them in the chat and the Q&A section. Thank you.
Thank you. So now you have understand the importance to manage acidosis in ruminants. I will present a solution that we have in Phosphia, which is calcium powder advance. So first, a short recap about mineral buffer solution. So what is a buffer? It's a compound that neutralizes the excess acid to maintain the pH in the rumen, if we talk about ruminants. And there are different types of buffer. The buffers that catch acid, like calcium carbonate or magnesium carbonate, but there are also some buffers that gives bicarbonate ions, like sodium bicarbonate, for example. There are also alkalizer products that raises the pH in direct proportion with the amount of product that is put in the diet. But now we will focus on calcium powder advance, which is a lithotamnium product. So calcium powder comes from living red algae. So it's a marine red algae that when it dies, its skeleton calcified, and we harvest this calcium skeleton. We dry it, we grind it, we sieve it to obtain calcium powder advance, which is composed of 33% of calcium and 2% of magnesium. So what are the objectives of the product? It is to stabilize the ruminal pH. We'll see that the product acts on a long term and progressively. So if we maintain the ruminal pH, we can have better performance with the animals. And how it works, it's working with a synergy between a mechanical action and a chemical action. So firstly, about the mechanical action. So the efficiency of calcium powder advance is linked with its porous structure. So that is what we can see on the right picture. If we observe with a with a microscope the structure of lithothamnium, we can see many holes in the structure. So that is what we call the pores. And to the contrary to terrestrial calcium carbonate, with which we can't see any pores, it's more compact structure. This difference allows the product to be more soluble, meaning that when we put calcium powder advance in a core rumen, for example, the product solubilization will be better thanks to the hole that increase the surface of contact, unlike the terrestrial calcium carbonate, which is harder to solubilize. It will allow after a better mineral bioavailability. If we go now to the chemical action, so there are two ways of crystallization of calcium carbonate. So two main forms, aragonite and calcite. So calcite first comes from a long sedimentation process. So it will produce a stable form of calcium and a low release of calcium. If we have a short sedimentation process, we will mainly have aragonite and magnesium calcite form of calcium, which are less stable forms compared to calcite, meaning that the calcium release will be higher. And what is interesting with calcium powder advance is that the product comes from a short sedimentation because it comes from a living organism. So the sedimentation is short, meaning that the product mainly contains aragonite and magnesium calcite. So now we understand that we have a good product solubilization and a good calcium release with calcium powder, which can be, of course, interesting for the animals. So now if we go to the strict mode of action, if I can call it like that, we will have two steps in order to maintain the rumen pH with calcium powder. The first one will be product solubilization. So as we see, this solubilization is quite good, and we have a good calcium release also, which will be the first step. So after product solubilization, we will obtain calcium ion, which will be absorbed easily by the animal. And we will have also carbonate ion, which will react in acid-base reaction. So as you can see on the formula, there are two minus with the carbonate ion, meaning that this ion can catch two acids. The first one with a total reaction, and the second one with a partial reaction. It is very important to differentiate it from sodium bicarbonate, which is also a very well-known buffer solution. When we look at the mode of action of sodium bicarbonate, we can see that the first step is the same, it's product solubilization. But in this case, we obtain bicarbonate ion with only one negative charge, meaning that sodium bicarbonate can catch only one acid. And that is very important because if we have on the one hand CPA, so calcium powder, that can catch two acids, and on the other hand sodium bicarbonate that can catch only one acid, it means that CPA dosage can be half dosage of sodium bicarbonate for the same efficiency to maintain the pH. So now if we go to trials to illustrate the efficiency of calcium powder, we can see on this trial that was made with Derico that if we replace sodium bicarbonate by calcium powder advanced, the rumen pH is maintained higher. So we have a good impact of calcium powder on the rumen pH, knowing that the dosage is half with calcium powder compared to sodium bicarbonate. We can also see on the right that the combination of the two products can also be interesting because we maintain a good rumen pH. If we go to risk of acidosis management, with on the left, the percentage of cows with a very low ruminal pH, as Nicolas explained, it represents and defines the acidosis. So we can see that with calcium powder advance compared to SBC, so sodium bicarbonate, the percentage of cows with a low pH is reduced. So we have a better management of the risk of acidosis with calcium powder compared to sodium bicarbonate. We also have a good impact of the combination. And on the right, it talks about the time that cows spend with a low pH, and we can see that with calcium powder, we really reduce the time with a low pH in cows. If we go now to the duration of the buffer effect, it is interesting to see that the calcium powder and sodium bicarbonate have different buffer effects. So firstly, we can see that CPA has a quite long and long-term and progressive buffer effect that can last for 6 hours, unlike sodium bicarbonate that has a flash effect for 1 hour. So that's why the combination of the two products could be interesting, because we can combine the flash effect of sodium bicarbonate with the long-term effect of calcium powder additives. So we have seen that calcium powder can help to maintain the rumen pH, which is very interesting in case of acidogenic diet. And it will, this maintain of pH will impact the rumen bacteria. That's what we can see on this graph. So if we compare a situation without any acidosis and a situation with acidosis and no buffer in the diet, we can see that cellulitic bacteria, so the light green, this population really decreased between the two situations. So we know that SARA, so acidosis, subacute ruminal acidosis, has a negative impact on cellulitic bacteria. This bacteria that digest the fiber, so we can imagine that fiber digestibility could also be impacted. If we now introduce calcium powder into the diet, we can see that we have a positive impact on cellulitic bacteria. The population is higher compared to diet without any buffer. So we have a positive impact of calcium powder on rumen bacteria. And this impact is quite better compared to sodium bicarbonate or compared to a terrestrial calcium carbonate. If we look now into fiber digestibility, so which is linked with cellulitic bacteria, we can see that talking about NDF digestibility, so the total fiber of the diet, the digestibility with calcium powder is a bit better compared to sodium bicarbonate and terrestrial calcium carbonate. And this difference is more important with ADF, so the fiber that is hard to digest. We can see that the gap between calcium powder and SBC, for example, is bigger. So we have a positive impact of calcium powder on the digestibility of the fiber in the diet. So if we look now at the performance of the animals, we can see that if we move from sodium bicarbonate, to calcium powder, the milk production can increase. And we can see that with different level of production, meaning for low producing, but also for high producing dairy cows. So we have a positive impact of calcium powder on milk production. We also have a positive impact of calcium powder on the milk quality. As we can see in this trial, milk fat content and milk protein increased with calcium powder compared to sodium bicarbonate. So how to benefit of these advantages with calcium powder? So the recommendation dosage are adapted to all your animals. For example, if you have dairy cows, the recommendation is to use between 70 and 100 grams of calcium powder per head per day. So this is a recommendation that can be adapted to your diet and to your own situation. For example, if you have heat stress period, you can adapt and increase the dosage of calcium powder. What is also interesting is to say that if you need a different form of calcium powder, you can have the form that suits the best to your needs, because we have 3 forms: a powder form, a granulated one, and a micronized one. So you can find a calcium powder that can suit your needs. So if we sum up all the benefits of the product, we firstly have a stabilization of the ruminal pH, which is progressive and on a long-term period. Cassie powder is a product that ensures rumen activity and feed efficiency because of its action on rumen flora and the fiber digestibility. Cassie powder also stimulates milk production and milk quality. We didn't see it in the presentation, but we also have good impacts of calcium powder on the performance of fattening animals with better growth. And finally, calcium powder is a source of available calcium for the animals. So it's a product that you can use to meet the demand of the animal in terms of calcium. And this has been proved in different trials around the world. Thank you for your attention.
Thank you very much, Canel and Nicolas for those presentations. I don't know if we have some question in the chat. I'm not sure. We have 5 minutes to ask your question. I have a first question for you, Nicolas. We talked a lot on the milk, the impact of the acidosis on the milk pollution. What is the impact, or if we have acidosis also on the meat cow or beef cattle?
Yeah, we basically a ruminant is the main function of a ruminant is to transform fiber in something interesting. So when we are in meat situation, we transform fiber in meat, fat, meat construction. So it's affecting also feed efficiency. It's not as sensible probably as high producing dairy cows because we are expecting a lot of intake and a lot of production, daily production. We cannot compare 40 liters of milk with 1 kilo of growth. But there is also, it's not good to put steers, for example, in feed too acidic situation. So something that has to be controlled. Not as sensible, but sensible. So and there is different trials showing this.
And I have a second question for you. If tomorrow on my farm I have acidosis on my cow, what are on the diet? What are the main action to do? It's add fiber, it's decrease cereal, or I don't know. And in how many time I can change sour or our situation in normal situation?
I should say it's case by case. You have to identify the problems. Might be, for example, the access to the feeding trough. If dominating cows are eating the good part of the diet and the dominated are just getting, so it might be this case. So you have to take care with the dominating cows, or you have to offer enough place for everybody. It's one of my recommendations is also to look at salivation. Salivation is very, very important because the natural buffer which is produced in huge quantities regarding what we can put in the feed, the endogenous production of saliva. So it's important to provide enough sodium to the cow. So salt blocks, for example, this kind of salt in the diet, or efficient fibers that are able to encourage the cow to say, for example, introducing barley hay, which is more interesting than wheat hay, because it's creating more salivation. Salivation is probably one of the survey heat stress. We are in a region where it's supposed to be not warm, so it's available for all the Atlantic zones in Europe, but we have humidity. Humidity is increasing the heat stress, so they have to be controlled. So we can have 28 degrees with 80% of humidity. It's a very severe heat stress.
Okay.
So it means that the diet has to be adapted. depending on the condition. That's very important.
So we have one question in the chat. What are the importance of the quality of the drinking water and the drinking water, so it can affect the women?
Yeah, of course it can, because the cow is drinking a lot. Particularly when the weather condition, of course, heat stress is also increasing the water intake. It's normal, but also the kind of diet. We have to give some rumination is asking also for big volumes of water. So the quality of water is important, as we pay a lot of attention to the quality of water in monogastric. That's also to be surveyed for cows. So acidic water might have an impact. Probably not the main impact, but marginal impact on the final pH, average pH, and probably comparing two groups of cows, one with acidic water and one with neutral water, might drive to because acidity is something, it's like temperature. It's very factual. You can measure it, and it's result you get it on your screen. Or it's not that evident with cows, but we have boluses, Wi-Fi boluses that give this kind of application. So it has to be considered if we are in a situation facility. But water treatment in general is important.
Yes. Okay. So we have time for one more question for you, Canel. How can we balance the calcium phosphorus with the calcium added from calcipoda addends?
When we talk about calcium phosphorus ratio with calci powder, we will take calci powder as a source of calcium, so it will not bring phosphorus. It means that in your diet, when you put calci powder, you can decrease a bit the source of calcium that you add at the origin. Meaning that, for example, if you are using terrestrial calcium carbonate as a source of calcium, you put calci powder into your diet, you can decrease in consequence, so the quantity of terrestrial calcium carbonate that you were using before. As TPA is bringing 33% of calcium, you can keep the same level of calcium, so you adapt the quantity of other calcium source. And about the phosphorus supply, you may need a phosphate in your formulation, because calci powder doesn't bring any phosphorus, so you need to keep your source of phosphorus and adapt the supply of calcium with incorporation of calci powder.
Okay, thank you. I think we yes, we have time for a last question. It's more
it's an environmental question. It's a very, very good question. Well, I think in the future, we are not talking about next year, but next decade, probably the cows also will be moving with the climate. I suppose that they will have also to follow the zones where we're able to grow corn, for example, or to grow grass or to grow alfalfa. So there will be this kind of phenomenon. But the cow by itself is adapting. Perhaps also we can wait from the genetic progress. It's something which is probably not followed right now, but the capacity of the cow to resist to heat, that could be also an interesting data to phenotype to follow. And well, there is different techniques also with ventilations, with water spraying, multiple strategies to resist, and taking examples from countries like Israel or like Arabic countries where they're able to grow milk in a very, very warm situation. So they also show the way somewhere. It's possible through cow management, through cattle management, through the feed solutions to grow dairy cows in severe conditions. Okay. Probably the challenge is in temperate zone. I think about Western Europe. I think about Canada, both sides of USA, where we have winters and summers, and it's where we have to adapt to do transitions. Transition is an important role, important name or word, sorry, in cattle management.
Okay. Thank you very much, Nicolas and Canel, for both presentation. And thank you for your participation.